Ever feel like technology is advancing faster than we can keep up with? You're not alone. Just a decade ago, most of us barely used voice assistants, and today they're practically family members. If you're curious about how we got here and where we're heading, stick around. I'm about to unwrap the fascinating journey of AI history, and trust me, understanding this story not only demystifies your gadgets, but also empowers you. Before we begin, hit that like and subscribe button, or an AI might confuse your digital footprint with a toaster's and sign you up for endless breadcrumb cleanup tutorials. From the very dawn of civilization, humanity has been fascinated by the idea of creating life through non-biological means. Ancient myths from Greece told tales of Hephaestus, the god of blacksmiths, crafting mechanical servants out of metal. We dreamt of the golem, a clay behemoth of Jewish folklore, animated to protect its people. And across the world, stories flourished of artificial beings, endowed with intelligence and purpose by their creators. These stories reflected our deep desire to imitate life, to mold our own assistants and companions in humanity's image. However, it wasn't until the 17th century that a glimmer of modern AI began to surface. René Descartes pondered the possibility of machines that could think, raising questions about the nature of mind and mechanism. And in the centuries that followed, innovators like Charles Babbage and Lady Ada Lovelace laid the groundwork for computation, exploring mechanical devices capable of complex, programmable tasks. Leap to the 20th century, where formalized logic and the burgeoning field of computer science began to turn these ancient dreams into tangible goals. Alan Turing, during the dark days of World War II, proposed the Turing test as a measure of machine intelligence, a way to assess a machine's ability to exhibit human-like thought processes. It was in the midst of this optimistic post-war era that the term artificial intelligence was coined. In 1956, a groundbreaking workshop at Dartmouth College convened the brightest minds of the time, John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, among others, to tackle the ambitious goal of simulating intelligence in machines. The foundations they laid during those formative weeks would not only name the discipline, but also establish its guiding principles and methodologies, setting the stage for the rapid advancements in the field that we witness today. Thus, from the flickering embers of mythology to the electrified circuits of modern computation, AI emerged, not as an overnight revolution, but as a journey through the collective human imagination, shaping the forge of science, one insight at a time. In the wake of the Dartmouth Conference, early AI researchers were animated by a surge of optimism. They embarked on a quest to construct machines with the ability to reason, learn, and ultimately, understand. These foundational years were marked by groundbreaking experiments and the early exploration of rule-based systems. One of the first major forays into artificial intelligence was the realm of game-playing computers. These machines, simple by today's standards, dazzled the world by playing checkers or chess at competent levels. They operated on a clear set of rules and strategies, hard-coded into their software, an approach that echoes throughout this era. But it was the development of rule-based expert systems that displayed AI's potential in replicating human expertise. These systems were designed to mimic the decision-making abilities of human experts in specific domains, such as medical diagnosis or geological prospecting. They analyzed data through a predefined set of if-then rules provided by human experts, allowing them to make reasoned judgments in their fields of programming. However, the most iconic of these early attempts at conversational AI was a program developed at MIT by Joseph Weizenbaum called ELIZA. ELIZA was simple but captivating. She generated responses to user inputs through pattern matching and substitution methodology, giving an illusion of understanding. Her most famous script, Doctor, emulated the responses of a Rogerian psychotherapist, leading some users to attribute human-like feelings and thoughts to the machine. Programs like ELIZA offered a glimpse into a future where computers could interact with users in a meaningful way, though they were limited by their reliance on pre-programmed responses and lacked any real understanding or cognitive abilities. Yet, it was in these formative moments that the seeds of modern AI were sown, showcasing the first steps towards creating systems that could engage and even emulate human thought processes. The anticipated bloom of an AI spring quickly transitioned into a harsh winter. The early advancements in artificial intelligence had sparked tremendous expectations. Experts predicted that within a few decades, machines would be capable of carrying out any work a human could. Unsurprisingly, these high hopes were premature, and the gap between ambition and reality became starkly evident. By the mid-1970s, the limitations of early AI systems began to overshadow their initial promise. Rule-based systems required exhaustive lists of possibilities to be effective, and they struggled to deal with real-world unpredictability. This rigidity exposed the hard truth that AI was still far from replicating the nuanced understanding of a human being. The absence of significant progress, coupled with inflated claims, led to widespread skepticism among government agencies and funding bodies. The result was the first AI winter, a period in which funding and interest receded like daylight in polar regions. Research stagnated, projects were shelved, and the narrative of AI shifted from one of certainty to caution. However, the cycle of hype and despair is a recurring theme in technological innovation. The late 1980s witnessed a revival of bold predictions as advancements in hardware and theoretical understanding generated fresh excitement. And once again, the bubble burst, leading to a second AI winter. Funding dried up, and the earlier condemnation repeated as AI failed to live up to another round of spirited forecasts. By the end of the 80s, it was clear, overcoming the intricate complexities of human intelligence was a far more challenging task than the pioneers of AI had imagined. The winters had laid bare a critical truth that progress in artificial intelligence would be a measured, incremental journey rather than a sprint to the finish. Amidst the chill of the AI winters, embers of innovation continued to smolder, heralding a resurgence of interest in the 1980s. This decade witnessed the revival of AI, particularly through expert systems, which seemed to fulfill the pragmatic needs of the industry. These expert systems were advanced, rule-based applications that soared in popularity for a time, despite being descendants of the same rule-based logic that faced criticism in the past. However, what set them apart was their focus. They were targeted at narrow domains, where they could harness a vast pool of knowledge provided by human experts to solve complex problems in fields like medicine, chemistry, and finance. Companies invested heavily in these systems, hoping to revolutionize the way they operated by tapping into the promise of automated expertise. These systems became a bridge between the lofty ambitions of general AI and the practical applications of what was then achievable. Parallel to the leap of expert systems, another momentous project emerged from the East. The Japanese government launched the ambitious fifth-generation computer project in 1982. This 10-year plan aimed to leapfrog the existing computer technology and create machines that could carry out intelligent processes, such as reasoning, understanding natural language, and learning, paralleling human cognitive abilities. The Japanese invested billions of yen into developing these Prolog machines, designed to run on the logic programming language Prolog, which was deemed apt for AI applications due to its declarative nature. The vision was bold, to catalyze a new era of computers, driven by knowledge and logic rather than mere data processing. While the fifth-generation computer project ultimately fell short of its lofty goals, it played a crucial role in spurring global interest and investment in AI. It awakened the world to the strategic importance of information technology and AI, engendering a new level of competition and cooperation that transcended national borders. This revitalized focus set the stage for what was to come, as researchers around the globe pushed forward, piecing together the intricate puzzle that is artificial intelligence. As the 1990s dawned, a realization took root within the AI community. The knowledge-intensive, rule-based systems that had been the focus of AI research were reaching their limits. These systems were brittle, expensive to maintain, and scantily adaptive to the variable nature of real-world information. It became evident that a new approach was needed, something that could handle the messiness and unpredictability of the data our world was amassing at an ever-accelerating pace. Simultaneously, the digital revolution was underway. The emerging internet began connecting the globe in an intricate web of communication, commerce, and data exchange. Vast amounts of information were being generated, and within this burgeoning digital realm lay the key to the next stage of AI: machine learning and data-driven approaches. Machine learning turned the traditional AI paradigm on its head. Instead of programmers laboring to input every potential rule, machine learning algorithms use statistical methods to enable computers to learn from and make decisions based on data. AI systems were now primed to uncover patterns and insights independently, evolving with every piece of new information they processed. Researchers began to develop a variety of machine learning techniques, from neural networks, which mimicked the workings of the human brain, to support vector machines, from decision trees to Bayesian networks. These methods could be applied to diverse problems, from speech and handwriting recognition to predicting consumer habits or analyzing financial markets. This data-driven renaissance was highlighted by several milestone achievements within the AI landscape. IBM's Deep Blue defeated reigning chess champion Garry Kasparov, signaling a shift in the public's perception of what machines could accomplish. And projects like TD Gammon used reinforcement learning to reach expert levels in backgammon, further underscoring the potential of self-improving systems. As the end of the century approached, AI was no longer just about simulating intelligence. It became an instrument to extract knowledge from the dataset of human experience, a tool of unprecedented power and potential waiting to unfold its chapters in the new millennium. The landscape of artificial intelligence has been marked by some truly game-changing moments, crystallized events that redefined what AI could achieve and shifted the perception of its role in our lives. Perhaps none was more striking than the moment when Google's AlphaGo program defeated world champion Go player Lee Sedol in 2016. Go, an ancient board game known for its deep strategic complexity, had long been considered a bastion that AI would struggle to conquer. AlphaGo's victory was not just a testament to advanced machine learning techniques, such as deep neural networks and tree search algorithms, but also a profound statement about the potential of AI to unravel complexities that were once exclusive domains of human expertise. Before AlphaGo's triumph, IBM's Watson had already made waves in 2011 by winning the quiz show Jeopardy! Against human champions. Watson's ability to understand natural language, process vast amounts of information, and respond with precision showcased an AI system extending beyond theoretical research into the realm of engaging with human language and knowledge in a practical setting. As these intelligent systems grew in capability, AI began to integrate more deeply into everyday life. From personalized recommendations on streaming services to virtual assistants in smartphones, AI's presence became a mainstay. Autonomous vehicles started navigating roads, and industrial robots became increasingly sophisticated, working alongside human counterparts. However, as AI became more entrenched in our daily existence, it also heightened ethical concerns. Issues began to swirl around privacy, surveillance, decision-making transparency, and the future of employment. There were fears over the encroachment of biased algorithms in critical decisions affecting lives, such as in law enforcement or hiring practices. Questions about accountability became pressing. Who would be responsible when an autonomous system makes a grave error? The excitement accompanying AI's breakthroughs walked hand in hand with a circumspect approach about its governance, use, and potential consequences. AI holds a mirror to the human condition, reflecting both the ingenuity and imperfections of our society. As we continue to push boundaries in AI research and application, grappling with these ethical dilemmas remains an ongoing, critical part of the story. This narrative continues to unfold, as our creations, once reflections of ancient myths, become tangible actors in the saga of human advancement. Thank you for joining us on this fascinating journey through the history of AI. From ancient myths to modern breakthroughs, we've witnessed the evolution of artificial intelligence and its profound impact on our world. We hope you found this exploration as enlightening as we did. Remember to hit the like and subscribe buttons to stay updated on our future videos. Your support means the world to us. Until next time, keep exploring and embracing the wonders of technology. Thank you for watching.